Alrighty, welcome fellow concrete preservationists. Welcome to Webinar Wednesday, hosted by the Concrete Preservation Alliance. You probably remember me. My name is Scott with Vector Corrosion Technologies, and I've been the moderator for most of these for the last year and a half, which has been fun. That said, it's a sad day today because this is our last webinar Wednesday of the parking structure preservation series. We've done 6 prior to today, ranging from a number of topics: concrete repair, investigation, corrosion protection, and today we have a really unique topic here today. Hopefully you'll stay for a cup of tea and maybe a biscuit, and you'll get that joke shortly. Let's just get on with the show here, and starting off, just briefly introducing the Concrete Preservation Alliance again. If you've heard me before, you know it's a group of like-minded organizations committed to advancing best practices in the field of concrete preservation and infrastructure renewal. We draw on all of our members to host these webinars and share their expertise and innovative technologies that they've found that have been helpful in projects, and today is no different. The home of the Concrete Preservation Alliance is WeSaveStructures.info. So if you've joined here today, you've probably registered for this webinar at that URL. Our members range all over the world, from Germany to Japan to North America to France. And like as I said, we use all of our members' expertise to bring you the best educational content possible. WeSaveStructures.info, as I mentioned, under the events tab, you can register for new webinars, and we are at present trying to put together another webinar series, likely in the fall, and we're open to suggestions for content and market sectors, industrial, marine. There's lots of places we could touch on, so we encourage you to provide feedback at communication@WeSaveStructures.info if you have suggestions. But enough from me. Let's get on with the show today. So our speaker today is Ryan Fleming. He's pretty much touched every part of Vector Construction where he works. As a manager of sales and project development, he's a certified engineering technologist. He's familiar with lean construction practices. He's an ACE CP1 or a corrosion technician, a corrosion technologist. And he also has extensive experience in estimating and construction. Just one other note, he's a Manitoba native, grew up on a grain farm in rural southwestern area near Margaret. Ryan is married and has 3 daughters to keep him busy. And in his spare time, he enjoys hockey, fishing, camping, and fantasy sports, and even a little bit of carpentry. I don't know how he has the time, but clearly he has a lot of hobbies. Before I turn it over to Ryan here, and Ryan, you can share your screen anytime. But before I turn it over here, for those of you who have questions, I encourage you to pepper him with questions throughout the presentation. The best question asked today will receive an Amazon gift card in the amount of $100. So please share your questions in the Q&A function on your screen. And without further ado, Ryan, are you ready?
I'm ready. Thanks for the introduction, Scott. I appreciate it.
There you go. Looks great.
I just want to thank everybody in advance for attending the webinar, and hopefully you'll learn a little bit about this innovative product called the carbon fiber T-Biscuit. As we go through the presentation, a little bit of an outline. I'll give you some background information on what the biscuit is, what its primary purpose is. Also, we'll deal with, also have a look at alternate applications for the product. I'll do a little bit of a walk back on the product history, amount of projects and installations that have been completed with the product. I'll walk through applications and also an installation process. We'll touch base on a case study for a project that was done in Texas, and I'll give you a little bit of information on the technical performance of the product, shear values, and at the end we'll do a little bit of Q&A. So what is a carbon fiber T-Biscuit? Basically, it's a carbon and glass fiber laminate. Specifically, the primary application is for the repair of failed flange-to-flange shear connectors of precast concrete T-beams. Basically, the biscuit itself is composed of layers of triaxial carbon fabric and with an exterior, on the exterior surfaces, glass fiber. So this is a photo showing a side profile of the biscuit. You've got your glass fiber on the exterior extremities of the biscuit, and the interior is that carbon fiber. The biscuit itself, the dimensions are shown here as being 16 inches long, 3-inch depth with a 3/16 thickness. The surface, in order to place into a Sawcut slot, the biscuit itself has a diameter, or sorry, a radius of 14 inches to mimic the plunge cut of a 14-inch quick cut saw. And also the surface is roughened, almost like sandpaper, so that when it's placed in the epoxy bed, it has a good adhesion factor. Just some history on the Double T itself. They've been in production since the early 50s, starting in Florida. And at one point in the mid 50s, they started adding pre-stressing to the girders, just to be able to extend the spans themselves or get a longer span. So there was a few different connection types. So the biscuit itself, as we get into what it's replacing with the previous connections between two Double T girders at one point was a reinforcing bar that was set in a grout pocket, and at each location, these locations here, 1, 2, 3, 4, a weld bar was put in so you could connect one girder with the girder beside it. So this was one of the original connections. You would set the bar, weld it, and then you would fill in the grout pocket just to finish off the surface. Then there was some innovation on that connection type, and basically what it came to was an insert that would go into the precast form at the flange, tied into the reinforcing steel, and then it had a flat weld plate that was showing on the flange face. And so this is one girder, this is the other girder, and you've got your flange weld plate, and then you would take a weld bar or rod and you would weld it to connect one girder to the other side. So the reason for part of the design in the T-Biscuit is with the T girders, what has been happening is when vehicular traffic crosses the T girder, there's a deflection that occurs. So as the wheels of the vehicle move across the structure, there's an impact from one side to the next, and it's putting a lot of stress on that welded connection. So over time and multiple cycles, multiple vehicles, also in some areas of your parkade structure, you may be subjected to higher traffic loading, or it's at the end of a ramp or the top of a ramp or a turning lane, where there just is a lot more impact on these welded connections. And what can happen is it leads to failure. Some of the failures that occur are at the actual weld of the bar in between the two girders. So the weld itself is actually failing. The failure can also occur from, say, differential settlements or potentially corrosion issues if this expansion or this joint isn't protected with a backer rod and caulking type cover or protection or waterproofing. This is just a full out failed flat bar connection. Basically, it's came right out from its two welds on either side. This is a little bit different of a failure. Again, it's a failure at the weld or right at the plate face. And lastly, this is also a round bar connection, not a flat bar. You do have a failure to the weld, but we're also starting to see failure on the precast itself. So when you get into this situation where you've not only getting the weld failures, but you're also getting a precast issue, or the precast is starting to crack and have issues. Basically, you'd be looking at previously a repair such as this detail, where you actually would remove the concrete at the connection, the full surface of the flange on both sides of adjacent girders. You would set back in a new weld bar. This actually shows an anode to help with corrosion mitigation. You would form up the new flange, pour it back with a repair mortar, and then finish it with a back rod and caulking, just to keep moisture ingress at a minimum. This is fairly extensive repair, and again, that would be when you have a failure of the precast. The T-Biscuit itself has been available for 12 plus years. 120,000 plus units have been installed in the US and Canada in over 750 parking garages. Basically, it's been installed in every US state except New Mexico, Idaho, North Dakota, Vermont, Maine, and Montana. So there is lots of background projects and different scenarios where the Biscuit has been utilized. Moving on to some of the design details. So if you had a project in mind, this is some of the layouts for certain projects. And in this case, basically this was a prescription of a one-to-one design. The X's are showing the existing welded connection. So you've got 1, 2, 3, 4 existing welded connections, and the design called for slotted T-Biscuits at intermediate points between each welded connection. And in some locations, a little bit of a safety factor. We've got 2 in this intermediate point here. This up here just is showing a side profile of the saw cut, and basically the dimensions of the overall thickness for a typical T-girder flange is approximately 4 inches. So you do your saw cut to 3.5 inches to set the biscuit within about a 1/2 inch from the bottom surface of the flange, and aiming to leave about a 1/4 inch to a 1/2 inch on the top side so that you can finish off the caulking across the joint. This is showing a profile from the other angle, just showing how the biscuit fits inside the saw-cutted slot. Here's a video. This is of a parkade with double T's, and basically the girders themselves, or in this case, I think the welded connections had failed along the entire length. And what the video will show is how the structure works as the vehicle passes across. So again, there's pretty significant deflection because those welded connections have failed. You get quite a bounce as the vehicle goes across and each set of wheels crosses the joint. Again, this is pre-repair, and I'll just play the video one more time. Oops. And I can't get it to play. There we go. So it's a considerable amount of movement between those two adjacent girders. This is an after repair video, and if you can see, it's hard to tell just looking at the video, but basically there is biscuit slots along the length, approximately every 2 to 3 feet. So I'm assuming that a welded connection is somewhere at the intermediate points of this length between these two girders. And when I play the video, you see that the deflection from girder as the car passes across the joint from girder to girder is basically mitigated. And I'll just play that video one more time so you can see the difference from the before and after. So again, the biscuit itself was originally intended specifically for double T girder flange-to-flange connection repairs, and typically in the parkade market. This particular structure is located in Winnipeg, and there has been biscuits installed for approximately 8+ years. Manitoba or Winnipeg goes through a pretty severe change in temperatures. In the winter, we're looking at minus 30 degrees Celsius, which is approximately minus 22 Fahrenheit, up to in the summertime at plus 30 degrees Celsius to plus 86 Fahrenheit. So there's definitely a lot of thermal action, that's thermal expansion and contraction in Winnipeg. So it's a good test for the product, as well as having that cyclical thermal change happening. In Winnipeg in the springtime, you can have, say, a 20 degree temperature differential from morning to evening. So there is the primary application of the product. There is also non-typical applications that we have utilized the T-Biscuit in. Again, that might mean a modification to the design to fit these applications. But some of the places that we've used biscuits in the past are slab on grade, so the joint between two slabs on grade. Locations of wall to floor, so that's this schematic this picture is showing the potential slotting in a biscuit into the corner if you had movement between the slab and wall, or the floor and wall panel. Also in the bridge deck, precast bridge girders on bridges, there is already a design for bolted connections or lateral post tension, or a grouted keyway that picks up that connects the two girders. But T-Biscuits could work in that location with the right engineering. Also, T-Biscuits can be used for crack repair on concrete slabs. Can be used to stabilize the cracks and joints. One thing to always keep in mind is to be aware of the cause of the issue. So if it's a slab on grade, potentially the reason that you have, say, differential settlement between the two slabs is a void that's below the surface or below the slab. So you would need to mitigate the void before you would do the repair. The biscuits themselves can be customized in size and shape to suit a specific application. They're cut on a water jet table, and depending on the application that you're looking for, we can basically work around quite a few different dimensions. Obviously, the highlight of the product is that you can use a 14-inch saw, concrete saw, to do the plunge cut, and that dimension of the biscuit fits right into that plunge cut of the concrete. There is product engineering available, and also we'll get into the testing that was done on the project or on the product later on in the webinar. It's not necessarily for concrete only. There is applications where we've used it in masonry and cinder block. One of the items that it was installed in was in a lighthouse. So the biscuits actually were able to fit into slots in the masonry, and we were able to design. They were able to be designed to fit the circumference, the circular lighthouse dimensions. I'd like to walk you through some of the installation details, just a little bit of an introduction on the system. So the biscuit by itself is just one component. We'll go through the materials and equipment required to install the product. It's actually a fairly small list. It's not a heavy burden of equipment or labor required. I'll walk you through setting your layout for where your biscuits are to be located. I'll touch base on saw cutting, slot preparation, and also preparing the biscuit and installation of the biscuit. And lastly, I'll touch base on some of the cleanup and curing that can help speed up that process. So as stated previously, T-Biscuits are custom carbon glass reinforced plastic laminates designed to repair those failed flange-to-flange shear connectors of precast concrete for single and double T-beams. It's a two-part system where you have the biscuit as part one and both a part A and B epoxy that the biscuit is set into. So some of the materials that you would need would be cardboard or a hawk board to mix your two-part epoxy. If you have available water on site, you can use a wet saw. That'll also help to keep the dust down. If you use a wet saw, you will have to pressure wash the slurry out of the joint afterwards and then allow 24 hours to dry. And then before you actually would install the T-Biscuit, you would still need to take a compressor and just blow out the joint one last time. If you use a quick cut saw, like the one shown here, it works fine. The only issue is that you will have dust. So depending on maybe some of the silica exposure requirements in your jurisdiction, you may have to wear masks, eye protection, things of that nature, but that's sort of regional dependent as to what those requirements are. You'll need a margin trowel, and this is to help place the epoxy into the cut slot. Also, nitrile gloves, definitely handy with working with part A, part B epoxy and mixing, and also working with methyl ethyl ketone or acetone to clean and prep the joints and the biscuits themselves. So when it comes to setting out the location of where the Sawcut slots should go, basically I follow the design criteria, make sure that you've looked into what your design needs to be. In most cases, what we're comparing is a 1-to-1. So for every one failed flange connection, you would add a biscuit in for each point or at intermediate points between those failed flange connections. If there's the requirement for a safety factor, like I showed on a previous slide, there may be at intermediate points 2 biscuits in between each, just to pick up additional loading. One of the things to keep in mind when marking the surface, it's best to use a bright, like a crayon type marking pencil. Red or black works well, but also when you're looking at where the biscuit location is on the top surface of the deck, you need to keep in mind what's going on the underside. 2 things that are important that you would need to point out from the underside is any potential conduits, electrical conduits, sprinkler systems, alarm systems, and also the other thing that you'd want to make sure and to confirm is the depth of the flange. And hopefully you're getting to that 4-inch flange depth, and both sides are equally the same depth, so that when you do your plunge cut, you're not protruding through the bottom or the underside of the girder. When you're get into saw cutting your slots, this is using a dry cut walk behind saw. Basically, what we're doing here is marking the depth with a crayon on the actual wheel of the saw, and then when you do your plunge cut, you can basically sink it to that point where you see the mark on the saw blade. Again, if you're creating dust, just make sure that you're following your local silica guidelines for dealing with that. And then once you've completed your saw cuts, you want to blow out any dirt and latenance. Again, if you use a wet method, you will have at least a 24-hour turnaround time to actually be able to place the biscuit. So if you use a wet saw, you wouldn't be able to install biscuits until the next day. But if you use the dry saw and you blow it out, you can basically do it, minutes within completing your cut. The next step is to clean and prepare the slot. So you would just take your methyl ethyl ketone, wipe the surface, take duct tape, and go around the perimeter of the saw cut. And the reason for that is as you place your epoxy, it's going to basically spread out over the surface, but you'll be able to remove that duct tape afterwards, and you'll get a nice clean finish, and you'll see that coming up. Next step is to prepare the biscuits themselves. Basically, you want to take that methyl ethyl ketone, clean all surfaces of the biscuit prior to placement. So you clean the biscuit, set it beside the install location, and then you can move to mixing the epoxy. The epoxy is equal parts A and B. Basically, you want to get a baseball size amount. You have the black and the white epoxy. You want to mix it to a uniform gray, and you want to ensure that you don't have any white or black streaks remaining after you've completed your mix. So once you've completed a uniform mix, you want to take your margin trowel and you want to fill the slot cut with epoxy, basically just along the entire length, fill it right to the top surface. Then you want to take your biscuit and you want to coat the exterior surfaces of the biscuit before you place it into the slot. Once you've placed it into the slot, you want to take your margin trowel and just ensure that it's set to the depth, basically a 1/4 inch to a 1/2 inch below the top surface of the deck. And you also want to ensure that you work out any potential air bubbles that may have came into play when you slid the biscuit into the slot. Once that's complete, you can take your margin trowel, strike the surface smooth and flat, and you can pull off the duct tape so that you get a nice uniform clean finish. Now I'm just going to play a little video that also covers the installation.
Traditional building materials have very distinct life expectancies. Steel reinforced concrete, for example, has a 40-year service life. Typically, due to normal freeze-thaw cycles, the concrete will crack, moisture will reach the steel, and it will then begin to rust and corrode. V2 Composites CFRP T-Biscuits offer an economical and proven way to restore the structural integrity of concrete structures and walls without large disruptions to operations. V2's patent-pending T-Biscuits are carbon fiber plates made from custom-designed triaxial fabric designed to repair failed flange-to-flange shear connectors of precast double T beams. The specially engineered triaxial fabric provides high strength, while a proprietary textured glass fabric is bonded on the exterior face to provide additional toughness as well as a rough bonding surface. Large-scale testing has shown that V2's T-Biscuits can withstand more capacity than metal systems. Prior to installation, clean each T-Biscuit with methyl ethyl ketone to remove any oil, dirt, or grease. This helps maximize the bond between the surface and epoxy. Use a concrete saw to make a cut 1/4 inch wide by 18 inches long at a 90-degree angle across the seam. The depth of the cut should be a 1/2 inch from the bottom of the flange of the double T. Typically, the cut is about 3.5 inches deep. Drop a dummy biscuit into the slot to check the depth. The T-Biscuit is shaped to mimic the curve on a 14-inch diameter saw that is used to make the cuts. Custom sizes can be made to fit the needs of the job. If the slots were dry cut using compressed air with a minimum of 100 psi, clean out the slots to remove dirt and dust. If the slots were wet cut, pressure wash the slots to remove slurry or dirt. Allow 24 hours to dry. Mask off the top of the groove with tape for a cleaner look. Mix V2's biscuit bond paste by measuring 1 part A to 1 part B by volume into a clean pail or onto a pallet. Mix epoxy by hand to achieve a smooth consistency and a uniform gray color. Make sure there are no white or black streaks left. Only mix the amount of material that can be used within the pot life. Large batches will set up much faster than small batches. The temperature must be 45 degrees or above. Fill the groove with a liberal amount of adhesive and work it in with a trowel or putty knife. Make sure it is applied to both sides of the slot. Next, apply biscuit bond paste to both sides of the T-Biscuit and place into the groove, working all of the air out of the groove with a putty knife. Then, insert the biscuit into the slot, pushing it all the way to the bottom to ensure proper depth. It should be countersunk at least 1/2 inch below the surface, allowing the caulking to go over the top of the biscuit. Allow epoxy to gel. Once epoxy is set, remove masking tape. Total cure time is about 8 hours. Normal operations can resume after that point. For more information, contact V2 Composites Inc. at 334-502-3000 or at info@v2composites.com.
So the installation itself is not overly complicated. Like I stated previously, the equipment to do the job is also it doesn't take a lot of equipment to get the work done. One of the things just to keep in mind, there is testing being done on the 2-part epoxy for a application at colder temperatures. Again, that's being worked on currently. So hopefully that means that some installations, especially in Canada, you could do installations, say if the temperatures are below 0. Next, I'd like to just walk you through a previous project, a bit of a case study for a project that was completed in Dallas, Texas, at the Cool Springs condo parking garage. The garage in the picture here is shown in the back of the building. Was built in 2004 by a precaster out of San Antonio, Texas. And in this structure in particular, since construction, there was issues with the connectors at the flange-to-flange, but the issue was not welded. It was not the welded connection that was failing. It was actually the precast that was the issue. So when it's that precast issue, that's when we're looking at a more extensive repair in order to pick up that loading. T-Biscuits were looked at as a solution, and basically we worked through a design that became a redundant design, basically a 1-for-1. So for every single welded connection, a biscuit was put in place, and nearly all of the weld clips on this particular structure were replaced with T-Biscuits. It amounted to over 2,500 units total placed. Again, the process was similar to what was shown in the installation video, except they used a wet saw, washed it out, and then did the biscuit installation. So they would have had a little bit of turnaround time, approximately 24 hours before they could get to the next step of doing the biscuits. I'd like to touch base on some of the technical performance or the testing that's been completed on the T-Biscuit itself. And the main purpose of that testing was to determine what the actual capacity of the biscuits were. The testing was performed utilizing the same recognized protocols for the previous connections, the welded connections or the bar connections for the flange-to-flange connector. And that data has been used to determine design values for current installations. The testing was done through an accredited testing facility, ZS Technologies, and they're located in Newcastle, Delaware. So one of the first tests that was completed was a vertical shear test. And basically a mock-up was made utilizing precast at different strengths. So we had 3,000, 5,000, and 8,000 PSI concrete. They set up a rig. A biscuit was placed into the slot and into the rig, and then the vertical, it was tested in the vertical plane. And so looking at the failure loading on 3,000 PSI, you always came to a concrete failure point and not a failure of the biscuit itself. It's not until about 8,000 PSI concrete or precast did we start to see biscuit failures for vertical shear. So from there, we went to horizontal shear testing. Same criteria, 3,000, 5,000, 8,000 PSI precast concrete. Same loading criteria. On the 3,000 PSI, we were getting failure of the concrete. Same for 5,000 PSI. Again, it wasn't until 8,000 PSI that we were starting to see the biscuit shear and biscuit failure, and that was getting to a loading somewhere between 20,000 and 24,000 pounds. So just to reiterate some of the benefits of the product since its introduction to Vector, some of the main highlighted items that I see as an advantage of the product is its ease of installation and that burden of not the burden of a ton of equipment required for it. You can use a small crew. You can keep those costs down in comparison to previous repair methodology. Since the biscuit is made out of carbon fiber and glass, you won't have to worry about any future corrosion issues. Typically, it's more conventional than it's more economical than a conventional repair. I would say with the intrusive full depth repair shown in previous slides, it could be anywhere from a third to a fifth of the cost. The product manufacturer itself, they have a certified installer program, so you know that the product is getting installed by trained and tested installers. Another advantage is the short-term disruption, specifically if you use the dry cut method. Basically, you could come in, do an area, and finish and have traffic back on that deck within about 8 hours. And lastly, the biscuit itself has been tested and proven, and it's equal to or better than the conventional connections that are in place. So how do we put the T-Biscuits to work? Basically, we're happy to help in any way we can. As far as investigation, if you need us to come and have a look at the structure and see what the issue is, whether it's a thermal expansion issue, differential settlements, or corrosion. We can help you identify the root cause of the issue. We can help you with design support. We have a lot of the testing criteria that we can share as you work through your design. When it gets to estimates and proposals, we are fully capable to provide those to you. There's already specifications and detailed drawings on hand that you can add to your documents, modify to suit. We can supply that as well. We can also provide installation support. We have crews available in most locations, and also there is the availability to train a local contractor if we weren't able to meet the needs of the project. And again, some of those non-typical applications, there may be something outside of what I've shared today that you may want to look at the Biscuit for confining or containing movement. Say it's for a large machine foundation base to stop vibration. Potentially, it's something that could be used. So think about some potential applications that you have in mind, and if they're outside the non-typical, we can discuss those. And lastly, we're available for being able to do inspections and maintenance of previously installed systems. Are there any questions?
Oh boy, are there questions?
There's questions. Perfect.
All right, let me just get set up here. This has got to be a record because you guys certainly want that gift card that I offered up. I have to give 2 this time around, Ryan. We have over 32 questions. So we're not going to get to them all, but we're going to do our best here. I'm going to ask the first one. And this is more of a joke, more of a comment than a question, but why are they called T-Biscuits and not T-Bones? Do you know?
Yeah, it's a good question. I'm not
All
sure.
right, first question from our friend Bargov. I hope I got that pronunciation right. Why does the connection have to be welded? Why not custom bolted with slotted holes? Just this in terms of the old connections.
Well, I think there is if you saw in the video, there is a bolted type connection. So there is iterations on the welded or bolted connection. So depending on what you've been exposed to, if it's a bolted type connection, that would be more in the case of maybe you need expansion for whatever reason, if you actually do want the movement. But the Biscuit itself is basically meant for confinement to stop that movement.
Okay. A question here from Anonymous. Is the use of carbon fiber T-Biscuit intended for pre-topped double Ts as opposed to double Ts with a cast in place topping slab?
I think it could be used in both applications. Again, it's just a matter of having the thickness, and also if it's a topping, you just want to make sure that the topping would be solidly adhered to the top side of the girder.
Okay, another question from actually our good friend Matt, longtime listener. He's a big fan of your show, so to speak. It's a longer question, so here we go. Are there concerns for enclosed garages or other structures which have a fire resistance requirement? Typically for FRP structural strengthening design, FRP systems effectively fail at epoxy glass transition temperatures, which can be easily achieved in a fire. Are you aware of any objections to the use of this system due to fire resistance rating concerns?
I probably would revert to the manufacturer on any sort of testing done in that, but I think it would also be based on the building code in that jurisdiction. So if it's an exterior parkade, I don't know if you'd have the same fire coding as an interior enclosed parkade. But yes, fire could cause an issue.
Okay, we can always get back to people on this directly after the presentation. We'll share your information, Ryan, so they can contact you directly. Another question, do the biscuits reinstate horizontal capacity of the connection, i.e. diaphragm continuity?
Basically, it's designed to match the loading that was on the previous connection. So yes.
Okay. Question from Gustavo. What's the structural capacity of a biscuit? How was the spacing determined? I think you've said before that the spacing mirrors the spacing of the prior connections.
Yeah, so it's basically the ideal design is 1-to-1. Sometimes there's a safety factor requirement. Also, that 1-to-1 design is under typical standard loading. So this would be, half-ton trucks, regular size cars. We're not talking about a location where you've got large equipment. So if you did have that case, then possibly the design would call for more biscuits at a smaller spacing.
Okay, we have more questions flowing in here. We're not going to get to them all here, but we'll keep going. In using a biscuit for a double T joint, would the failed shear connectors still need to be repaired or rewelded, or are they essentially abandoned?
They're completely. They could be completely abandoned. Again, if you just want to have a redundant system, you could still repair the welded connection, have the biscuit in place, and so then you're basically doubling the capacity. But again, you may have to worry about confinement. If you're confining that joint too much, it may transfer some of the movement to some other location, maybe at the ends of the girders as it's tied into the structure.
Okay, some of these questions will require some kind of maybe follow-up discussion, so we'll make sure that happens. Question from Mosen. Is the repair to be applied from the exterior side, like near surface mounted techniques, but instead of FRP rebar or the tape that's used often, our T-biscuits are used instead? Is that correct?
I'm not sure, actually.
Okay, no, we can ask for clarification for we can go back. Gary's asking another question. Can T-biscuits be used for crack control in water retaining tanks? The other option for crack control is chemical grouting.
I would say as long as we could walk through the intended engineering design, it could be a potential application.
Okay, some more longer questions here. Anonymous is asking, using a T-biscuit as a repair option for crack repair on a slab on grade, do you think that this may be a better option than epoxy sealing the crack from a long-term performance standpoint? Would this product help resist localized negative flexural cracking, as in corridor cracking in warehouses between storage racks?
I do not know if it's actually been used in that application, but from what I see for that case, I don't see why it wouldn't work. Basically the exact same. So you could tie that corner back into the slab itself and actually prevent that from happening in the future.
Okay, more questions keep coming here. John Myers is asking, my understanding is that the T-biscuit would normally replace the previous double T connector locations, but has any detailed research been undertaken to examine spacing variation and how that affects adjacent double T behavior over time?
That one I would definitely revert to the manufacturer.
We might have to offer up 2 gift cards because this is a really good set of questions. He goes on to say, or have you developed any spacing recommendations for double Ts? And if so, what were the recommendations based on? I have only seen individual T-biscuit component tests in available literature, i.e. direct tension, shear, to generate failure loads for different load applications.
So again, it comes back to that one-to-one design that when in comparison with the testing criteria that was completed, a one-to-one design is typical. So again, the spacing requirements, you're fitting those biscuits in between at the intermediate points between the failed flange connectors. So depending on the spacing of the failed flange connectors, you're going to be mimicking the spacing of those, just offset as you're placing the biscuit in between those locations.
Okay, I'm going to give Matthew 2 questions back to back here because they're kind of connected. For precast tees, have the biscuits been tested yet for adequate lateral resistance during an EQ or wind event? This is the primary function of a T connection.
That's a good question. I would have to revert to the manufacturer on that. I know they have other testing, some testing that is still scheduled to occur. I'm not sure if that includes for lateral.
Gotcha. So he goes on to say, also, has any further research been conducted on why cracking and spalling sometimes develops around biscuits after installation in double T flanges?
Just the weakest points. So from the sawcut being placed, you still may have the movement is still greater than, and so the precast fails. The biscuit still staying in place, but the precast still can fail if there is a lot of either differential settlement, corrosion, or a lot of deflection that's occurring, a lot of traffic. It's in a location that takes a lot of impact, say at the bottom of a ramp. Possibly what it would mean is that you need to add more biscuits along the length.
Okay. Quick question from Richard. How many cycles of fatigue are the biscuits designed for?
I would have to ask the manufacturer on that one.
No worries. Okay. See a question from Colin. Is the product only applicable for double T flanges with a minimum 4-inch range thickness? If so, is there a traditional patch repair? Is a traditional patch repair really the only option for repairing failed flange connection for flanges less than 4 inches, topped member, for example?
I guess that the biscuit itself could be modified if you had a shallower flange, say it was 3 inches. We would still, because the testing was done on the standard 4-inch flange thickness, we'd probably have to go through the testing for a shallower flange.
Alrighty. Here's one a little bit atypical question from Anonymous. Have you done, I guess the answer would probably be no on this, have we done, but have you done this on a bridge deck, widenings? Does AASHTO or federal highways allow for these T-Biscuit applications?
I would have to refer to the manufacturer for that, especially on a widening of a structure. But again, if the existing connection, if it's a bolted or it's lateral PT, and that's what we're picking up, as long as we're meeting that loading, I don't see why it couldn't work, and I'm not 100% sure if it's a part of AASHTO.
Okay, maybe I'll pull the last question here. There's still more coming in, but the last question here, and we'll give you a break, is more on cost. So can you give any kind of perspective on cost? I know obviously every project is different, quantities, application, etc. Is there a typical cost for a T-Biscuit application? And there was a question specifically related to a quantity of, say, 100. Is there any kind of guidance you can provide, or would you like to speak directly with these gentlemen?
Well, I think it would be best to touch base again. If it's 100 biscuits, we could be at it could be a $300 to $500 installation per biscuit. It really depends on the amount, what methodology is required, location. There's lots of different things in play there. But again, in comparison to the other repair methods, the intrusive full depth, it could be 1/5 to 1/3 the cost to use biscuits instead. So it's quite economical.
Okay, well, you know what, there's still more questions to come, but we're pretty much closing on time here. So, Ryan, thanks for being a good sport and letting us pepper you with questions. Though his contact information is up on the screen now, so feel free to continue the peppering. And I just realized that we have your mobile number on there, so feel free to give him a call directly. He likes calls night and day. So I'll leave that contact info up right now. This is the time I'd normally say, our next webinar is 1 month from today, and we have this topic coming up. But as I mentioned, this is our last parking structure preservation webinar of the year, and we're moving on to different topics in the fall. If you have any thoughts or recommendations or requests of areas to cover, please let us know at communication@wesavestructures.info. We're looking forward to seeing how we can better serve you guys out there that are you're saving structures. So brings us to the end of today's presentation. I'd first like to thank Ryan for sharing his experience and expertise in this topic and this innovative tool that you may not be aware of. Thank you, Ryan.
Thank you very much, Scott, and thank you to everyone that attended.
And thank you again to everyone who joined us, whether it's your morning, afternoon, or evening. We appreciate your time and your attention, and we hope you go out there and save some structures. Be safe, everyone. We'll see you in the fall.